I want to define what is a random variable in this video. So we often use this term random variable, which is abbreviated as RV, many times in probability and statistics. But to be able to understand the meaning of what a random variable is so much critical, and more often than not, the concept is not well understood. So let's define what a random variable is. And what is this randomness comes from, what is this variable, all those things, putting it together is a little bit confusing. So in probability and statistics, let's take probability. We have a sample space. That sample space is a space that consisting of different events, all possible events, right? This particular sample space depends on what your problem is at hand. Suppose is a if we say x is a random variable that is counts the number of heads. Let's take a specific example. After 3 flips of a coin, right? So that means the sample space consists of all possible values of 3 flips of a coin. That is head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So you can actually put these values right here. For example, your sample space just changed into only consisting of these events, right? Head, head, head. I'm not going to write all that. So as you can imagine, there are 1, 2, 3, 4, 8 events. So there are total number of events in this sample space, which we call it as S, is 8, right? So now when we say x is a random variable, what it really means is where does the randomness comes from? The randomness comes from, you do an experiment. You take a coin, flip it 3 times, and you note it down. What's the outcome? So in this particular case, let's say you got heads, heads, and tails. So this is an experiment that you did. The outcome of it is the randomness of one of the events happening, and that's what is a random variable means. So in this particular case, x is assigned HHT, but HHT doesn't make much of a sense unless you assign a value to it. So as you can see, in this particular case, random value is the count of number of heads, right? Count of number of heads. In this particular case, your x will get 2, right? So let's write down the value here: 3, 2, 2, 1, 2, 1, 1, 1. These numbers are just the number of heads in each of these experiments. So a random variable x gets 1, 2, or 3 values, right? So in fact, now let's define what a random variable is. Random variable is a function that takes the outcome of an experiment, right? Outcome of an experiment, and then assigns a value in the real space, right? That's what a random variable is. So hopefully, once if you understand this, many other aspects will become a lot more clear. So again, let's redefine what a random variable is. As soon as somebody says, hey, x is a random variable, there are a couple of things that you should be asking in your mind. Okay, is it represented as some kind of a syllable? And now if it is, what is the equivalent value of this random variable? What are the possible values of this random variable? In this particular case, it's 1, 2. You must have one more here. Tail, 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 which is 0, right? So it is Oh, that's right there. We got it right there. So 0, 1, 2 or 3 heads. So those are the possible values of this. So that is the first question you must be asking. Anytime somebody says, what's a random variable? X is a random variable. So, okay, now what are the different possible values that X can take? The next thing that you should ask yourself a question is, what are the distributions of these values? So, what is the probability of getting 0, probability of getting 1, probability of getting 2, and probability of getting 3. So now if you look at the definition of what a random variable on Wikipedia, random variable is a function that assigns the outcome of an experiment to the random event that may result from that experiment to a real value, out of which for each one of those values there is a probability distribution associated with it. So each probability of 0 is in this particular case 1 over 8, right? How many times we get 1? 1, 2, 3. So that is 3 over 8. 2 is 3 over 8. Probability of 3 getting is 1 over 8. Now the sum of these, probability of 0, 1, 2 and 3, 1, 2 and 3, the sum should equate to 1, and it does in this particular case, 1 over 8, then 1 over 8 is equal to 1. So these are all the properties a random variable must satisfy. Then so hopefully this cleared the understanding of what a random variable is. Sometimes this word is thrown and not really well understood. So from now on, again, to reiterate, a random variable, the moment somebody says what X is a random variable, you must be asking yourself a question: what are the real values it can take? It can take discrete values, just like the way how we said it, 0, 1, 2, 3, or it can take continuous variable from minus infinity to infinity, and any of those things. But you must be clear of what is that thing is. Next thing is, what is the distribution? What is the in case of a discrete variable, we say probability mass function. In case of a continuous distribution, we call it as a probability density function for this set of values. Now, the reason why we call it as a probability mass function is you can think of discrete values as happening, right? And then you can assign a value 0, 1, 2 and 3. As we calculated, the value of probability of 0 is 1/8. You can think of it as a mass, the weight of this particular thing or the event, or you can think of it as a pebble in the pebble world, and then the sum of these should equate to 1.